Today's topic is equation of a straight line. As you know, we have different forms of equation of a straight line, but we are going to consider the gradient and intercept form first. So the gradient and what? Intercept form. So I'm going to have, we are going to have xy plane. So we are going to have xy plane. So this is y-axis, and here is x-axis. So we now want to consider a straight line, LP. So we consider a straight line, LP, in which the coordinate of P is of, P is of coordinate x, y, and the L is here. Then the intercept of LP at y-axis, so this is y-axis, this is x-axis. Then here is the origin. Then the coordinate, the y-intercept of the line is C. So the next thing to do is to form a right angle triangle at point C. So you draw this line along the x-axis. So then you draw the line from P up to this point. So the angle between the horizontal axis and the line is given as theta. So we now form a right angle triangle. So the next thing to do is to locate point X and point Y. So to this point, taken to x-axis, this is our X. So that is for point P. It's of coordinate x, y. Then from point P again to the y-axis, we have y. Then the difference between y and c, that is the difference between the coordinate of P along the y-axis, which is y, and the y-intercept of the line LP, which is at point C, is y minus c. Then the difference along the horizontal axis, that is from x up to the origin, is x minus 0. So using the gradient formula, by making use of trigonometry ratio, is going to be opposite all over adjacent. That is tan theta, which is equal to opposite. Opposite is y minus c all over adjacent. Adjacent is what? X minus 0. As you remember, tan theta is the same thing as the gradient. So once the angle is given and you are looking for the gradient will be equal to tan theta. So we now change tan theta to what? The gradient. So because L is the same thing as the gradient. So gradient, L is the same thing as the gradient and is equal to the what? Tan theta. So in place of tan theta we have F, which is y minus c all over x minus 0. So the next thing to do is to rewrite and make y the subject of the formula. So we now have y minus c equals to m into s minus 0. So y minus c is y minus c equals s minus 0 is x. So we now have m into s. So we have y minus c equals ms. So we now have y equals ms plus c. So this is equation of this is an equation of a straight line given the gradient and the intercept form. Intercept form in this sense means y-intercept, not x-intercept. So it's now going to be y equals to mx plus c, where m is equal to the gradient. So m is the gradient and c is the y-intercept. So this is the proof of gradient and intercept. So let's move to the first example. So the example says, example 1 says, a straight line makes an angle of 30 degrees. A straight line makes an angle of 30 degrees with the positive x-axis, and cut the y-axis at y equals to 5. Y equals to 5. Find the equation of the straight line. Find the equation of the straight line. So let's look at this question. The question says a straight line drawn from the center, the straight line makes an angle of 30 degrees with the positive x-axis. So let's have our xy plane. So solution. So let's have our xy plane. Y-axis, then x-axis. So we have x-axis, we have y-axis. So the straight line makes an angle of 30 degrees with the positive x-axis. So if you look at this side of xy plane, this is positive x-axis, then the other side there is negative x-axis. But a line makes an angle of what? 30 degrees with the positive x-axis. So it means our x-axis is there. Then cut the y-axis at y equals to 5. So the up here is positive y, assuming it is negative y, y to the minus 5, we are using the down part of y-axis. But we are making use of the upper part of y-axis because our y is positive. So we now have this. So let's just have the rough sketch. So this is the line. This is the line. So the line makes angle 30 degrees with the what? With the x-axis, which is the horizontal axis, and cut the y-axis at y equals to 5. So let's assume this is y equals to 5. Then the angle is 30 degrees. Find the equation of the line or of the straight line. So to get the equation of the straight line, don't forget the general form of equation of the straight line when gradient and intercept form is given. So the equation of a straight line is what? Y equals ms plus c. So that's the first equation that we prove here. So y equals what? Ms plus c. So now to get the gradient is given as, we are given angle of the slope. So angle of the slope is, or angle of the line is theta equals to 30 degrees. I've told you if theta is given, the gradient will be given as m equals to tan theta. And m will be what? Tan theta is what? 30 degrees. And what is tan 30 degrees in short form? That is 1 all over root 3. So tan 30 degrees is 1 over root 3. But remember this, we have two types of the slope. We have the positive slope and the negative slope. So if our line runs as we have it here, it means we are going to have negative slope. But from the proof of the first theorem, of the gradient intercept form, so the proof here, the type of line we have here, the slope we are going to be having under this graph is going to be positive because we move from the down part here up to we have positive slanting line, but here we have negative slanting line. So here the gradient will be negative, but here the gradient will be positive. So that is why our m will now be minus 1 all over root 3. So you now go back to the equation of the line. The equation of the line is given as y, which is equals to ms plus c. Remember, y will still remain y and x will still remain x. So because our straight line must be in form of x and y. So y is y, x is x. So what we just need to do for is m and c. And we know our m to be what? Minus 1 over root 3. And our c is what? Y-intercept. And y-intercept is given as 5. So just conclude and write your equation in form of the straight line equation. So y equals to m, which is minus 1 over root 3 x plus C, y-intercept, that is 5. So we now simplify this. If you like, you can clear the denominator. So multiply through by what? Root 3. So if you multiply through by root 3, so this equation becomes root 3 y equals to root 3 multiplied by minus 1 s root 3. So root 3 will got root 3, you'll be left with minus x, then plus 5 root 3. So you can as well write it as x plus root 3y equals to 5 root 3. So this is the equation of the line. So this is the equation of the line that makes angle 30 degrees with the positive x-axis and call the y-axis at y equals to 5. So that is that for example number 1 undergraded and intercept form. Then question number 2 says, what is the y-intercept and the gradient of the line? Number 2, what is the y-intercept and the gradient? What is the y-intercept and the gradient of the line and the gradient of the line whose equation is s over 5 plus y over 3 plus y over 3 equals to 1 over 3 question mark. So the question says, what is the y-intercept and the gradient of the line whose equation is s over 5 plus y over 3 equals to 1 over 3. So the first thing to do is to clear the denominator, then after that we make y the subject of formula. So we want our equation to be in form of y equals ms plus c. So that's our aim. So solution, so we have x over 5 plus y over 3 equals 1 over 3. So clear the denominator, so you take the SEM. So the SEM is 15, so you can multiply through by 15, multiply through by 15. So s over 5 multiplied by 15, 5 and 5, 1, 5 and 15, 3 multiplied by 3x, plus 3 and, y over 3 multiplied by 15. 3 and 3, 1, 3 and 15, 5. So 5 multiplied by y, that's 5y equals to 1 over 3 multiplied by 15, that is 5. So the next thing to do is to transfer 3s to the other side. So we have 5y equals to minus 3s plus 5. So divide through by what? By 5, by 5, by 5. Because we have to make y the subject of formula. So y will now be equals to minus 3 over 5x, then plus 1. So you can now compare this with y equals to ms plus c. So if you compare y is y, then m is gradient. You can now say, since we are looking for y-intercept first, and y-intercept is what? C. So you can now say y-intercept, which is equals to c, is equals to what? So compare this with this, that is 1, and gradient m equals what? Minus 3 over 5. So the gradient is minus 3 over 5, while the y-intercept, which is c, is what? Is 1. So that is that one. Example 2. Number 3. Find the gradient of the line whose equation is, whose equation is a minus bx in bracket, a minus b in bracket s, then plus c minus d in bracket, then y equals to E minus F. So find the equation of a straight line. Find the equation of a straight line whose equation is given as A minus Bx plus C minus Dy equals E minus F. So our aim is to make y the subject of formula so that we can express this in form of y equals ms plus c. So the first thing to do is divide through by what? By c minus d. So we have a minus bx plus c minus dy equals e minus f. So divide through by c minus d, then c minus d. So if you divide this, cut this, so you are left with y equals to, then transfer this to the other side, that's minus a minus b all over c minus d x, then plus e minus f all over c minus d. So if you look at this equation now, so it looks like y equals ms plus c. So since we are looking for the gradient, and the gradient here is m, so f will now be equals to, so m, which is the gradient m equals to minus a minus b all over c minus d. So you can as well write it as b minus a all over c minus d. So just open the bracket with minus. So minus times a, it will be minus a, minus times minus b, it will be plus b. So we now write it as b minus a over c minus d. So that's the gradient of the line given. Example 4. The intercept which the line 2x minus 3y minus 5 equals 0 makes with the y-axis is of, so is of what? So that's what we are looking for. We are looking for the intercept which the line 2x minus 3y minus 5 makes. So the next thing to do is to express this equation in form of y equals ms plus c. So where y is y, s is s, m is gradient, and c is the y-intercept. So make y the subject of formula. So we have 2s minus 3y minus 5 equals 0. So if you make y the transfer minus 3y to the other side, so it's going to be 2s minus 5 equals 3y. So you now write it as 3y equals 2s minus 5. Then divide through by what? Divide through by 3. So over 3 over 3 over 3. So y equals 2 over 3 x minus 5 over 3. So if you now compare this with ms plus c. So it means the gradient is 2 over 3, while the y-intercept is minus 5 over 3. Therefore, the intercept, the y-intercept is equal to c is equal to minus 5 over 3. So that's what we are looking for. So the last example under this gradient and y-intercept. So question number 5 says the equation of a straight line which makes an intercept of minus 2 with the y-axis and an intercept of 1 with the x-axis. So we have two ways of solving this. So the first method is going to be when you are given two intercepts, that is one on the x-axis and the other on the y-axis. So we are going to apply this formula that says s over a plus y over b equals 1. So where a equals to x-intercept S is y x-intercept, and A is x-intercept, and B is y-intercept. And S-intercept is given as 1, and Y-intercept is given as -2. Just substitute, we have X over A. A is 1 plus Y all over B -2 equals to 1. So we now have X over 1 plus minus is minus Y over 2 equals 1. So you now multiply through by 2. So if you multiply through by 2, we have 2x minus y, because y over 2 times 2 is y, then equals to 2. So we now have 2x minus y minus 2 equals 0. So the equation with the two intercepts, minus 2 and 1, is given as 2x minus y minus 2. So the second method is this. So we are going to have our xy plane. So we are going to have our xy plane. But remember, the x-intercept is at y equals to minus, y-intercept is at y equals to -2. So we are making use of the negative side of y-axis. So the negative side of the y-axis is this, the down part of y-axis. Then we have positive x-axis. So our line will be in this form. So the x-axis is at S is 1, Y is 0. Then at y-intercept, which is S is equal to 0, Y is -2. So the origin is S, 0. But mind you, the gradient is given as y2 minus y1 all over s2 minus s1. So going by these 2 points, so when S is, okay, this is our x1, y1. We are going to look for the gradient first, which is y2 minus y1 over s2 minus s1. So you have labeled s1, y1, s2, y2. So our y2 is what? -2 minus y1 is 0 all over s2. s2 is 0, then minus s1, 1. So which is equals to -2 all over -1, which is equals to what? 2. So which is equals to now. So the gradient is 2. So you can now go back, since we are looking for the equation of a line. So the equation of a line will now be y equals ms plus c. That is gradient and intercept form. So the gradient is, y equals to the gradient 2. So we now have 2x plus y-intercept. Y-intercept is -2. So we now have -2. So y equals 2x minus 2. So you can transfer everything on one side. So it's now going to be 2x minus y minus 2 equals 0. So if you compare the two answers, you can see they are equal. So that is that on gradient and intercept form. Thank you. So that is that on gradient and intercept form. So that's all.